Staying on it because the shielding is obviously a critical aspect of VFD cable installations. To stay on that for one more point here, I'm wondering about if a manufacturer discovered that a VFD installation where the shield wasn't properly terminated. You've talked about how you supply different parts to be able to do that, but how difficult is it to retrofit these existing installations that weren't shielded properly, and what type of improvement, if any, can be expected from this?
Well, if they've run shielded cable but just have not terminated it correctly, I think there's a good chance that we can help them with some accessories to install that. For instance, installing an EMC plate at the drive isn't going to take it's going to take a very little extra room. Hopefully, they have room inside their cabinet to do such a thing. To use a standard cable gland versus an EMC cable gland would take no additional space at all. So it would be something that likely could be done. The more common problem I see, however, is when somebody installs a non-VFD cable, a non-shielded cable, and then they have issues and they want to go back. Let's say they're running conduit. A lot of times the conduit is not sized such that they can do that. They'd have to repull the conduit. Turns into a real nightmare. It's very expensive to change the cable out in these systems.
Now, for the paper and the research in that, you tested several termination methods, and as you mentioned earlier, drain wires for one, and you also tested term kits and many others, of course. But for a facility without specialized expertise in this area, which of those method offers the best balance of performance and ease of installation?
Great question. And there's a huge difference in performance. In fact, one drive manufacturer, when talking about drain wires, for instance, which many times the copper braid shield products will have a drain wire incorporated into them. I don't even like that we put that drain wire in the cable because we're tempting electricians to do the wrong thing. But one manufacturer cited a study that showed at 1 megahertz, and we're talking typically up to 30 megahertz frequencies. So at the low end, very low end of that, at 1 megahertz, 2 inches of a drain wire, the impedance of that is equivalent to about 500 feet of cable shield.
Wow.
So I jokingly say, don't use the drain wire, just connect a wooden spoon up to from your drive to your motor, because it's about the same impedance, right? It's just, it's not worthwhile at all.
Not a good idea. Yeah.
No. But fortunately, the term kits are very easy to install. The glands are very easy to install. So you really don't need a lot of specialized expertise. We even have YouTube videos online to show how to install the term kits, for instance. So, and we're always available to do either a Teams meeting with people or come on site in cases of larger installations and do training.